Hello everyone. So far in the first video, we discussed what a polynomial is. We also discussed what an exponent is and what a rational function is. As well, we discussed what an asymptote is and how to locate them vertically and horizontally. Now in this video, it may be a bit longer than the first one, part 2 of the beauty of mathematics. We're going to be discussing something much more broad in terms of information, that is, remember from Algebra 2 where they told you about a concept which is the quantity of a base being raised to give us a fixed number? Yes, I'm speaking of logarithms. In this episode of the series, we'll be discussing logarithmic functions. Before we begin, we need to discuss properties of logarithmic functions. The first one is the multiplication property. So, what is up with this property? Well, in simple English, the multiplication property is the log of a product that is equal to the sum of the logs. The proofs of the multiplication property would follow. For any positive real numbers, x, y, and b does not equal 1, log base b, x times y. You would put left and right arrow here, which indicates the process can be reversed. Log base b, x plus log base b, y. The second property would discuss the division property, or, if you'd like to call it, the quotient property. If we wanted to state this property, we would say that the log of the quotient is equal to the difference of the logs. Now, I think you get what this property is stating. For any positive number, x, y, and b does not equal 1, log base x over y can be reversed to log base x minus log base y. Now, let's speak of the third property, which is the power property. For this, we would say the log of a term to a power becomes the power times the log of a term. Proofs of this would begin again with, for any positive real number, x, y, and b is not equal to 1. For any real number, log base x to the power of r can be reversed to r times log base x. Now let's speak about one more thing. There is a special log. It's called the natural log. It's written as ln, which makes it special is that its base is assumed to be e. E is called Euler's constant. For me to clearly explain Euler's constant, I would have to use techniques in calculus, so this video isn't going to be discussing that, or to explain how to perform it, nor is it to explain how to do anything like a tutorial. I cannot stress that enough. This is simply how to explain why these specific mathematical principles work, and that being said, I do believe I should explain Euler's constant formal definition. Euler's constant is a mathematical constant that is the base of a natural logarithm. The unique number whose natural logarithm is equal to 1. Euler's constant is approximately 2.7128, and the limit is 1 plus 1 divided by n to the power of n. As n approaches infinity, the expression that arises is the compound interest. Also, it can be calculated as the sum of the infinite series. So, what I wanted initially for you to take from this video is the relationships between logarithms and functions, and the ability to represent those graphically. Logarithms have many real-world applications. Yeah, I know. One of those would be the decibel scale. If you don't know what the decibel scale is, it's a scale that's used to measure the loudness of a sound. What's cool is the scale is logarithmic. At Mark 10, it's 10 decibels, which 10 is decibels more powerful than 0. Mark 20 decibels means it's 10 decibels more powerful than Mark 10. However, 2 decibels is 100 times more powerful than 0. So, you can see how mathematics can be used for science. It's actually quite amazing how the universe's laws of science is governed by mathematics. Physicist Max Tegmark at MIT quoted it this way in a Nova's documentary called The Great Math Mystery. Our universe doesn't just have some mathematical properties, but only mathematical properties. So, being the young math enthusiast you are, you can see where I'm coming from for why this is cool. Again, I hope this video somehow changed your perspective in a positive way. Now, what's to come? I intend to cover videos covering the Fibonacci and gold sequence. Now, these last videos, especially the last one, will take a bit longer, as you know, for a lot of people. Not most, mind you, but for some. School got out in May, so school for me starts in August 9th. I'm currently teaching myself AP Physics 1 over the summer, and I study nonstop, and it's hard to study and cut in hours to make a quality video. It can take me literally hours just to edit together a decent video due to me not having enough time or experience. So my last video will consist of the overall message of the series, and I'm kind of debating on making more than just 4. But we'll cross that bridge when we get there. If you guys want me to cover some specific concepts that you personally deem cool, I will look into it. But it's time to wrap this one up, I think. And I hope you guys enjoyed. Live long and prosper.